Hello everyone, welcome back to MAC1140 pre-calculus. So far, one of the concepts we learned that is different from college algebra is the we talk about the Gauss theorem, right? The remainder theorem and the factor theorem and so on. The decoded root sign, those concepts is totally different from a college algebra. You probably never learned those concepts in college algebra before. We're getting toward the end of the semester. There will be more concepts that's just different from the concept in college algebra. One of the concepts I mentioned and we talk about today is probably some of you never know that, you never seen that before, and you never touched that in college algebra. The concept we call the partial decomposition, partial fraction decomposition, and this concept is nothing but it is related to you might have to use the matrix concept we learned before to do this. So the concept must be related to matrix, the row reduced echelon form or echelon form, and it's also related to fraction, because that's why we call that the partial fraction decomposition. In elementary school, you know that if we have a fraction, for example, like for example, I have something like 5 over 7, right? And 5 over 7 is nothing but 3 over 7 plus 2 over 7. So you see that if you had a fraction, you can go ahead and split it up into a smaller fraction, right? To the smaller fraction. I mean, it's bigger or smaller depending on the fraction you have here, but you can go ahead and split up into multiple fraction. For example, over here, I can split up into 3 and 2. So the concept of splitting up right over here, the process of splitting up over here in pre-calculus, we call that decomposition, because in pre-calculus we have to deal with a rational expression. And think about it, if you have a rational expression, rational expression is nothing but fraction, and we can split it up, we can decompose them into many rational expression, multiple rational expression. Then we can take integration, and that's why this concept over here is very important. Is if you any of you want to go to have a level math and pre-calculus, to go to calculus 2, 3, then partial fraction is very important. Okay, so let's see how we're gonna decompose a rational expression today. Okay, so I'm gonna put the topic for today. So topic for today will be partial fraction, decomposition, okay, partial fraction decomposition. I mean, we split it up into multiple rational expression. Okay, we already know the rational expression is in this form, right? Our x rational expression would be p of x over q of x. Okay, and p and q over here is polynomial. And in this course, we actually in the homework we will be focused on the case when you have the degree of p of x is smaller than the degree of q of x, and this is the case we're going to consider. Okay, if the degree of p of x is greater than the degree of q of x, then we have to do one more extra step, which is the the division, the division, long division or syntactic division we already learned before. So I'm gonna focus on I'm gonna do many example, okay, and those examples could be related to the case when we have degree on the top is less than the degree at the bottom, okay, and so there could be another case, okay, the degree on the top is greater than the degree at the bottom, okay. So two different cases. And in this case, in either case, the cube x, okay, the cube x, which is the denominator, it could be in a linear form, or it could be in non-linear form. The linear form I'm talking about in this case will be this one. Okay, actually we have only one linear form, right? And this one we call that linear factor. Okay, later on we call it linear factor because we want to put the cube x into a factoring form. And another case where you're going to see will be a quadratic form. It's a non-linear factor, non-linear form. So must be this one. Okay, so we call this one is quadratic factor. Okay, quadratic one, and this one later we call a linear factor. Okay. Okay, so the process of splitting up those, okay, this fraction here into many rational expression, we call that partial fraction decomposition. So I'm going to split it up. For example, I'm going to split it into 1x, and I split it into 2x, and so on and so on, and x. I don't know how many. Okay, so it depends on how many factor in the denominator over here. So I'm gonna jump to the first case. Okay, so the first case. So case 1. So we have only two cases. Okay, so the degree, okay, on the top is less than the degree at the bottom. Oops, yeah. Sorry. Okay, I'm sorry. So the cube x. Okay, and for this case, I'm gonna split it up into a smaller case. So I'm gonna split it up into the first form. I think we have 4 different forms. So we're gonna split up the case 1 into the first form. I'm gonna call the form number 1 right here. And the form number 1 is the one we have denominator is the product, okay, which is the denominator cube x. Cube x is a product of distinct linear factor. Okay, it's a product of distinct linear factor. You know what? I'm gonna use different colors, easier for you to see. Okay, let me use different color here. Let me see. I can use this one. So cube x is product of distinct linear factor. Okay, so cube x in this case will be this. Will be something like this because it's a product of the linear factors. So it will be a1x plus b1 times a2x plus b2 times a3x plus b3, and so on and so on, right? So that is the form of cube x. Then if you have cube x at this form, then we will have r of x, which is your rational expression, will be something like this, right? It will be something like so you have a cube of x and cube of x here, and on the top, because you have the linear factor, so p of x you can split up the whole rational expression over here as a1x plus b1 plus b2x plus b2 plus c a3x plus b3, and so on and so on. It depends on how many linear factor you have over here, but all of them must be distinct. It must be different from each other. Okay, now let me give you the first example right here for the first case. What if I have the question that is partialize the fraction, partialize the rational expression 5x plus 7 x to the third, okay, plus 2x squared minus x minus 2. So this sometimes the question could be something like decompose this fraction, or sometimes they put partial fraction decompose. So, kind of the same thing. You partialization, or it's the same thing. It's the same thing. You just basically split up into multiple rational expression. That's all. Okay. Now you look at this rational expression. You see that. The cube x, which is the denominator over here. Okay, the denominator over here is a third degree. It's a cubic, and this is not linear, right? It's not linear, but so we have to convert this into the linear form. We gotta convert it into the linear form. So we know the x to the third plus 2x squared minus x minus 2. Here you go ahead and grouping. Okay, so I assume everybody know how to do this, because this is the kind of this is a part of intermediate algebra. So you do the grouping and you factor them out, and you see that you have a different square right here. Okay. So you have the three linear factor. And you can write this fraction 5x plus 7 over x to the third plus 2x squared minus x minus 2 into many factor form like this. So it will be into the a, right? A, the first linear factor. Okay. B, the second linear factor. So we have only three linear factors. So we have A, B, C. Of course, if you have more, then you have more letter, A, B, C, D, or whatever it is. Okay. Then what you have to do next is you have to find the least common denominator here. Well, you gotta find least common denominator here. So you're gonna have x plus 1, x minus 1 here, and then we have b x plus 2 and x minus 1 here, and you have c x plus 2 and x plus 1 here, and the denominator will be x plus 2, right? X plus 1, x minus 1. Alright, then you go ahead and distribute them. So you have x squared minus 1. You distribute this one, you will have b. Okay, so I assume everybody know how to do distribution. Minus plus x minus 2. And over here you have x squared plus 3x plus 2, right? Okay. You have x plus 2, the denominator. X plus 1 and x minus 1. Then after you distribute it, you have to distribute the a letter also. You can distribute that one. So you will see that. Yeah, you see that. So you have ax squared minus a plus bx squared plus bx minus 2b plus cx squared plus 3cx plus 2c over everything to over the bottom. So you have x plus 2, x plus 1, x minus 1. Then you have to factor them out. We'll factor them out, and you look at the top and see this is 5x squared plus 7, and this is the highest degree, this is x squared. So we gotta factor the x squared out. So you can have a plus c x squared, right? A plus c, a plus b plus c, actually a plus b plus c x squared. You have a b right here. Okay. Okay, plus c x squared. Then the second one must be this, the one with the x, right? So you have do we have ax or do we have anything? Right? So we have b, we have 3a. 3a, where's 3a? I think I missed something. Which well, we have actually we have oh yeah, oh x plus 1 is 3. So we have a square. Oh, okay. So we're second one we have b only, so we have b plus 3c. Okay. Do we think anything with x over here? Nope, we don't have it. Then the last one we have 2c minus 2b minus a. Okay, make sure you have all the terms. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 over the bottom. X plus 2, x plus 1, x minus 1. Alright, now you're gonna go ahead and match it up. Okay, so you see over here we don't have the second degree, so it means that the coefficient, we're gonna go ahead and match it up. The coefficient over here will be 0. Okay, that's the first equation we're gonna have. The second equation will be plus 3c. The coefficient in front of the x over here must be 5. And the last one will be 2c minus 2b minus a equals 7. Okay. Okay. Then what we have over here? We had a matrix right over here. Okay. We had a matrix. You can reduce echelon form, or you can use the matrix equation. Now we already learned last time you can use the calculator to solve for this one. So the first matrix will be what? The first matrix will be this, right? So it will be 1, 1, 1. So it will be 0, 1, 3. It will be negative 1. B could be negative 2 and 2, right? That's the first matrix. Then we had a column matrix that we are looking for. So we have A, B, and C. And at the way we have the end. The other column matrix, right? And you can solve for A, B, C right here using the inverse in your calculator. So you can have inverse of this one multiply by this one. Okay, so we're gonna do the inverse of that. So I don't have to do this, okay, because it takes a lot of time. I assume everybody know how to deal with inverse or to deal with inverse matrix and with the matrix. Yeah, so you raise this and you multiply it by this. Okay. Okay, here you go. And you're gonna have that. If you're gonna find the final example, the final answer. I mean, if you don't have a graphing calculator, the calculator you can deal with the matrix, then you have to use the row reduced echelon form right here. Reduced echelon form in order to get the ABC. Okay. And at the end, you get a find ABC. You get a find ABC. Over here could be a column matrix. You will end up with as far as I know, it will be ABC will be 0. B Ax plus 2C VA. I believe that you will end up with let me see, x minus 1 over so this will be 2. That's what I already solved. So it will be 2 right here. X will be negative 1. So B will be negative 1. and x plus 2 will be your a. Will be negative 1. X plus 2 will be negative 1 also. So you have a, b, and c, and at the end your rational expression will be something like this: 5x plus 7 over x to the third plus 2x squared minus x minus 2. Okay, and you're gonna have your a will be minus 1 x plus 2. Your b will be minus 1 again, minus 1 x plus 1, and then you have 2x minus 1. Here you go. You see that this rational expression we split up into 3 rational expressions. So we just decompose this rational expression into 3 smaller rational expression. That's why we call that decomposition, partial fraction decomposition. Okay. So you see that for only one example, it takes a lot of time already. So we're gonna, as long as we understand the concept, we should be okay. Okay, you gotta practice a lot to be able to do all of this, and it's easy to get mistakes. So you have to be careful. Okay, you have to be careful. All right. Now the second form I want to mention. Okay. Form 2. I think we're going to jump to the next page. Okay, so form 2 is that the denominator is also a product of linear factor. So Qx is also linear product. Is product of linear factor. However, some of the linear factor here is some of them are repeated. Some of which are repeated. Repeated, it means it raised to the second power, or raised to the power that more than 1. So if you go ahead and look at the first one, all the power here is the first power. So whatever the second power, the third power, and so on, it means they are repeated. For example, I have something like this. 2. So let me, before we start the example, I'm gonna write you the form first. So your cube of x must be like this. So ax plus b, a1. Then you have a2 ax plus b square plus a3 ax plus b raised to the third. So you see that this linear factor is repeated 3 times. So we start with the first degree because it's repeated 3 times. So we start with the first degree, the second degree, and then the third degree. For example, I have something like this. Let's I have a rational expression x squared plus 1. Let's decompose this x minus 1 squared. So you see that this rational expression here. My denominator is a product of linear factor because the x minus 1 square is nothing but x minus 1, and you see that this factor right here is this factor is repeated. Okay, so let's see how we're gonna decompose this one. Okay, let's see. Okay. Okay, so you see this linear factor is repeated. So so we're gonna use this form to rewrite this rational expression. So we have something like this. Okay. So x minus 1 square. So we have a for the first linear factor, b for the for the, you can do A1, A2, it doesn't matter. But I'm going to use AB, so for the second factor. And because this one repeated, so you're going to use that for the next factor. And you're going to do the same way. You're going to find LCD and so on. So over here you're going to have a x minus 1 square. Over here you're going to have b bx x minus 1. And then you have c cx. And then you have x minus 1 x minus 1 square. Then you distribute it. But in this one, I might use, let's see, we can use a different way to find ABC. You might go ahead and let x equal 1. So if x equal 1 right here, you will see that this is cancelled out. So we have a c of x equal x equal 1, plug it over here, the numerator. So you have c of x equal 1. Okay, so we got x equal 1, so you have c equal 1. Okay, c equal 1. Oh, let me see. I think I copied it wrong. It should be repeated 3 times. Okay, that's okay. I think I'm gonna do repeat it 2 times only. Alright. But what I had in my note is 3 of them repeated, not just 2. But that's okay. So I have c equal 1. Now, when x equal to 0, whatever x equal to 0, let's see what happened. And x equal to 0, so you have a 0 here, a equal 1 also, right? Because this is 0 over here, 0, 0, 0, 0, 0, everything can. So you have 0, negative 1 square. So a equal 1. So you need to find b only. So in order to find b, then finally at the end we still have to matching up the coefficient. So over here, had to expand them. X squared minus 2ax plus a bx squared minus bx plus cx. Okay, x minus 1 minus 1 square. So over here I factor them, so I have a plus bx squared. You have negative 2a minus bx. And then you have a plus c plus c. And then you have a. You have a. So you see that you have a equal 1, right? You go ahead and match up the denominator. Okay. Then because equal to 1 and a plus b, we know we matching up a plus b equal 1, right? A plus b equal 1 right here. We match up the coefficient. We're matching up the coefficient right here. And because a equal 1, so b must be 0. Okay, b must be 0. So for this one, so AB, so we got all 3 ABC already. So my final answer will be x squared plus 1 over x minus 1 square. You will have 1 over x. B equal to 0, so you have c equal 1. So 1 over x minus 1 square. Right? I just want to check if you have we got everything okay. I think we have something wrong. So you have a equal 1. Because if we have negative 2a minus b plus c equal 0, and C and A equal 1, so you have -1 minus B. C is also 1 equals 0, so B equal -1. This is much better because but over here we have A plus B equal to 0, A equal B equals A equal 1, A equal 1. I have a careless mistake, but I don't know which one. So let me see. Let me check it one more time. I have x minus 1. I have b x. We have x minus 1 square. X minus 1. And over here you have x. Okay. I just want to check if everything is okay. Look like everything is good. A plus b square minus 2a minus b. Let's see. I probably calculate something. Let's see, equal to 0, 0, 0. Oh yeah. I think I have something wrong right here. When x equal to 0. Okay, 0 squared, so this is 1. 0 squared, A equal 1. A equal 1. B equal -1. I don't know. There's some careless mistake. I couldn't find it. B equal -1 because it's totally different right over here. When we try to find a B, we have two values of B, which is I don't know which one is. I think this one is much better because we match it up. So we have -2a minus b plus c equals 0. C equal 1. Oh, C equal 2 right here. Yeah. X equal 1, right? 1 was a resistor. 1 cancel. C equal 2. Okay. Alright, so we got it now. So this equal 2. So B still give you 0. Yep. Okay, so you see that either way, you still got B equal to 0. You can pick one of the way to find B. So B equal to 0, so we don't have this one, and C equal 2. So you have 2 right here. Right? Yep. And that's the final answer. That's the final answer. So the process is kind of the same thing, you know. Nothing changed. It's still the same. All right. So that's the form number 2. Now, the form number 3. Okay, form 3. Now we're going to deal with the denominator of quadratic factor, and its quadratic factor here is irreducible. Actually, if you look at this is also quadratic factor, right? But this is reducible because this x minus 1 square is x minus 1 times x minus 1 is reducible to linear factor. Some quadratic factor is not reducible. For example, something like this. So cube of x. Irreducible. Irreducible quadratic factor. It means you can factor into linear. Okay. What if I have something like that? I have now then the form will be something like this. You will have Rx P of x over Q of x. And on the top, instead of just a number, you could have a linear factor on the top, and the bottom you have ax plus b x squared plus by equals c. This is the quadratic factor, irreducible. Okay, irreducible. It means that you cannot factor. It means you cannot factor this one. It means unfactorable. Unfactorable. That's what irreducible means. Okay. Now let's take a look at this one. Example number 3. So I have a rational expression like this. You have 2x squared minus x plus 4 over x3 plus 4. If you go ahead and factor this one, so this is not linear and quadratic yet. So you factor this, so you're gonna have linear and quadratic. And this quadratic here is you cannot factor them all. You see the x squared plus 4 is not a different number square. So this is irreducible mean. Okay. So let's see how we're gonna do this. Okay. Okay. So we're gonna have the top like this, and because we have a linear factor, so we're gonna keep it in the same way as we did in the first example. So you're gonna have ax, but because this is non-linear and irreducible, so we're gonna have bx plus c as the linear, and over here we have x squared plus 4. Okay, and now we're gonna find LCD and stop. Everything is still the same. Okay. Okay, everything is still the same. And you distribute them. Okay. Okay, and you factor them. So you have a plus bx squared, so that you can match up with the coefficient. Then cx, then at the end you have 4a, and you have x squared plus 4, and you see that we're matching up with it. So you're gonna have a plus b equal 2, you have negative 1, c equal negative 1, and 4a equal 4. So 4 equal 4, so a equal 1, and from here, so you got a equal 1 also. Right? Then at the end, my rational expression will be split it up as follow, because a equal 1 and b also equal 1. Okay, so you have 1 over x, b also 1, and c equal to 1, so you have x minus 1, c negative 1, plug it in here, over x squared plus 4. There you go, final answer. Okay, very easy, nothing hard right here. Okay, all right. So that is the form number 3, and the last form. So this one irreducible, and none of them repeated. So I'm gonna add a little bit on which is non-repeated. Okay, which is of non-repeated one. Okay, and form number 4. Form number 4. And when we have irreducible quadratic factor, non-linear, but this is repeated. So q of x here will be repeated, irreducible quadratic factor. Okay. So you're gonna have r of x here, and then p of x over q of x. And then because it's repeated, so you can have a1x b1 over ax plus by x square plus by equals c. Okay. Then a2x b2, then ax square plus by plus c raised to the second power. You see, repeated. And a3x plus b3 over ax square plus by plus c raised to the third power, and so on and so on. Okay. Alright, for example, I have something like this. Example 4. Whenever I have rationalized, we have a rational expression like this. We have x to the 5th minus 3x squared. Oh, minus 3x squared. Now plus 12x minus 1 over x to the 3rd. This one reducible, and it's repeated. This one is non-reducible right here. You see, quadratic non-reducible, and this one also non-reducible, repeated 3 times because it raised to the 3rd. Alright, so let's see how we're gonna rationalize it. So you have this. So this is reducible, and so to become a over x, repeated, b over x squared, repeated 3 times, over x to the 3rd, plus dx e over x squared plus x plus 1 irreducible, and because it's a quadratic, so the over here must be linear. It's quadratic, so it must be linear. df g h f g irreducible, repeated, I square plus 3 square j x k over x square plus 3 raised to the 3rd. And so you see that it's very, very complicated. If you have, I mean, it's not hard, it just takes a long time. You have something like, you're gonna, let's think about it. We gotta find LCD over here, right? It'll be crazily, and you know, so you're gonna have a matrix, and this is the row of the column must be 11 row, 11 columns. It's gonna be crazy in order to solve something like this, right? But this is the concept. This is what it is. If you do manually right over here, there's no way you can get it. I mean, you probably you can set it up, but in order to get A, B, C, D, F, G, H, I, J, too many variables you have to find. Then there's no way you can find it without a calculator. Even the calculator, I think you can do it. There's a matrix of 11 column, 11 row, but manually in order to do this, no way you can do this manually. Okay, so I'm gonna stop right over here for the form number 4. Now go back to the case 1. So the case 1 over here, the degree is of the top is less than the degree at the bottom. Then what is case 2? Case 2 case 2 is for the degree at the bottom. Okay, is the degree on the top, so it will be p of x is greater than the degree at the bottom. So last time is less than. You see, last time is less than. You see, less than. Now it's greater. If it is greater than, okay, if it is greater than, then you gotta use long division. Or you can use you cannot use synthetic though, because if it is greater than 1 degree, then maybe you can use synthetic. Then, but it's Oh yeah, I think you can use synthetic. I'm sorry. You can use synthetic, but the synthetic will be tough because it depends if the denominator is a linear factor. If the denominator is the first degree, then maybe in the form of ax plus b, then you can use the synthetic. If not, then 99.5% you have to use the long division here. So for example, I have something like this. So you gotta use long division, okay? So you have a p of x, right? You have p of x over q of x. Then when you divide it, okay, when you had a quotient, right? You had a quotient. Then you have the remainder here, right? That is the rule we learned a couple months. We learned several weeks ago. And over here you have q of x. And in this case, the r of x, which is the r of x over here, we have the remainder. This is the remainder. The degree here must be smaller. So which is r of x, the degree of r of x here must be smaller than the degree of q of x. So after the long division, you see that our case 2 go back to the first case at the new polynomial q of x, which is the quotient. Okay. For example, I have something like example number 5. Whatever I have this 2x to the 4. You see, this is the 4th degree plus 4x to the 3rd minus 2x squared plus x plus 7. Okay, over over x to the 3rd plus 2x squared minus x minus 2. Alright, so the degree on the top is greater than the degree at the bottom. We're gonna do long division. And we don't have any other choice. So we set up a long division. Okay, so you have x to the 3rd, 2x squared minus x minus 2. Okay, you set up long division. So x to the 4 plus 4x to the 3rd minus 2x squared plus x plus 7. So they have enough on the term, so we take this, go into this. So you have 2x, right? Distribute them back. This will give you 2x to the 4 my plus, so 4x to the 3rd minus 2x squared minus 2x, and then you do a subtraction. Everything cancel. Then you have 3x plus 7, drop it down. Alright. I think it should be 4 actually. That should be 5 right here. Then you see that you cannot do then you see that you cannot do anymore. You cannot do any do the division anymore because the degree over here is bigger than this. So the remainder is right over here. The r of x right over here. So my fraction, my rational expression can be q by quotient. Quotient is this. So quotient is 2x. Quotient is this plus the remainder and over the top. Oh, let me pick a different because this is quotient. I should use different letter because we have p and q over here. So I'm gonna use quotient here. I'm gonna do this q here, quotient. All right. There you have the denominator. You have x to the 3rd. X to the 3rd plus 2x squared minus x minus 2. And now you see that over here you see that you can factor more and blah blah blah, and you see that you can factor if this one is the linear factor or the quadratic factor, or it's a reducible or irreducible. So you basically repeat the step we already did in the first. For example, for this one, so there's the difference between the first case and the second case is that for the second case we just need to do a lot of division in order to bring it to the first case. Now, okay, very simple. So I'm going to stop right over here. I think that's good enough for you to grasp the concept. You can, I mean, this thing is not hard, but you have to practice. You must practice, okay? Otherwise, you never get used to it. So I'm going to stop my lecture video over here. Please let me know if you have any concern, any question. Send me the message through Canvas, okay? I'll be seeing you next time for the new video. Bye bye.